Hello everyone and welcome to another video of Vivek Learns. So in the last video we had solved two problems of recursion, right? Print increasing and print decreasing. So let's just recap what we did for those. So what we did was first we set the expectation, then we set some faith, right? And then we saw how we can reach from that faith to the expectation. Then we wrote it in a generalized form. Then we draw the stack trace or the stack diagram, like how the stack frames will be loaded. And then we identified a base case. And we identified the base case and then we introduced the base case in the code and then we ran the particular code. So in this video, let's continue with some other problems. So the next one that we are going to solve is factorial, right? So you are given a number n, you are required to calculate the factorial of a number. Don't change the signature of factorial function. Yep. So we'll be following all these steps that we had written here, right? So let's consider that we have a function called fact. And if we give an input as 5 to the function, what it does is it gives us the factorial. And how does it do that? It gives 5 times 4 times 3 times 2 times 1. And we have established a faith that we already know the factorial, right, of 4. And what is the factorial of 4? It's 4 times 3 times 2 times 1. And how do we reach from the belief to the expectation? What can we do? So what we can do is that we can have 5 and we can multiply it by factorial of 4, right? So this is how we can get the factorial of 5. So how can we write it in a generalized form? We can have n as 5 and then we can have fact of n minus 1, right? Correct. So let us draw the stack trace for this, right? Let me open Paint. So now we are going to identify what is the base case for this, right? So the first call will be fact of, let's say we give input as 3. Okay, so n will be 3 here, right? So let us try to have that class created first and then we can go to the stack trace. So we create a class called factorial where we take an input and fact. We call this fact function. So what we need to do is we need to have print something like n times n factorial, right? So for that, what we can do is we can directly return it. That's what we can do, right? So or we can break it down into further steps, right? So what we can do is that we can find first fact of n minus 1. Let me do it that way. So we'll be returning int, correct? What this will do is it will get me previous fact, and then what we need to do is we need to have it stored in some another variable, right? Fact, current fact, let's say. What will be the value of this? It will be n times the previous fact. And then what we do is we return current fact. That's all right. Yep. So let's have this code here in the IDE. Yep. So what we can do is that let's say this is line number 1, this is line number 2, right? This is line number 3. So when the first line gets executed, what happens is another stack trace will be formed with fact of n minus 1, which is fact of 2, correct? Here n is equals to 2. When the first line of this gets executed, what will happen is it will call another method which is fact of 1, right? And when the first line of this gets called again, it will call another method, it's fact of 0, correct? Where n is equals to 0. And forgot to mention here that n is equals to 1, correct? And if we don't have any base condition, then what happens is we'll keep on going. So we'll get fact of minus 1, then we get fact of minus 2, and so on. And then eventually we may get a stack overflow exception. So let's have a base case defined here itself, right? So we can have the base case as when n is equals to 0, then what we can do is that we can return 1 because factorial of 0 is 1, correct? So what we can do is that, let me come to the code. If n is equals to 0, then return 1, correct? So what happens now? Let's see the stack trace now. So it comes here and we execute the second line, correct? So previous fact, what will be the value of previous fact here? Okay, so base case is hit here. So the value of previous fact will be the value which is returned from here, which is 1, correct? So the value of current fact will be n times 1 because value of previous fact was 1, correct? So this is what we get the value of current fact, and then in the third line what we do is we return it. So this track trace will be erased and whatever the value we have it comes here, correct? So what will be the value of current fact here? The value of previous fact from the previous track trace was 1. The value of n is 2, so 2 times 1, right? Times, this is times 1. This will be the value of current fact, which is the second line. And for the third line, what we have is we delete this stack trace, we return with the current fact. So what will be the value of the current previous fact for last stack trace? It will be the value which is returned from up, which is 2. And what is the value of the current fact? It will be n, which is 3 times 2, which is 6. So this is how we'll be able to get factorial of 2. So we have executed both the lines here, right? 2 and 3. And once we get this, we return it, and when we delete the stack trace. So we'll need to print the particular value as well. So what we can do is that we can print it here. So let's try to run it. So factorial of 5 is 120, right? Yep. Let's try to solve another problem, which is we solve this factorial one, which is power linear and logarithmic. Okay, you are given a number x, you are given another number n. You are required to calculate x raised to power n. Do not change the signature of function. Correct. So we are given a number x, right, and n. Let's say power of x raised to n, x comma n. And what we have to do, we have to multiply x n times, right? So let's consider an example here. So let's say we are given 2 and n is 3. So what we'll have to do, the expectation is we have to multiply 2 3 times. And what is our expectation? Let's set our expectations that we multiply 2, we, sorry, we have 2 raised to power 2, which will automatically give us 2 times 2. Now how do we reach from the fact to the expectations, right? So what we need to do is that we need to multiply x, no, let's consider 2 with the power function, which is 2 times 2, 2, so 2, not 2 times 2, 2 comma 2. And if I try to write this in a generalized way, right? So this will be x times x times power of, what is this? What is this? This is x. This is n minus 1. Correct. So let's try to have the stack trace for this. Let me delete this. Let's try to first create a class. Named power. To open that class first, and so we need to take two numbers. Enter its power, which is power. Let's see. Then we need to give num comma power. We'll need to take another input here, power. And what we need to do is we have to multiply x by power of n minus 1, a power of x comma n minus 1. So we first need to call the power function with, let's have this as xn, this value as n. So we need to call x comma n minus 1, correct? We need to store it. Let's say previous power. Then we can have a similar, oh, we need to change the return type, correct? Okay, we can have similar variable called current power, which is x times previous power. Okay, so we have to return current power. Let's try to have this code and analyze it. So let's say this is the first line, this is the second line, and this is the third line. Yep. Yeah. So let me draw some stack frames here. Okay. So we have to solve it. Let's say we'll solve it for power of x, which is 2 comma 3, where n is equals to 3 here, right? So when we get this first one, right, like the first line executed, what will happen is it creates another stack with the value power of 2 comma 2, and this is for the second one, right? Sorry, so this is the first line which gets executed, and then again a new stack is created with value power of 2 comma 1. And when the first line of this method gets executed, what we do again is we'll get power of 2 comma 0, and we can have the values of n as the last value, like here n is 0, here n is 1, here n is 2, and here n is 3. So this is how we can have it. And if we don't have any base case, this will continue on. This is for n is equals to 0, then minus 1, minus 2, minus 3, and eventually we will get a stack overflow exception. So we need to have some base case here, and let's identify the base case as when n is equals to 0. So when n is equals to 0, then any number raised to 0, what it does, it returns 1, right? Any number raised to 0, it will return 1, correct? So, or we can have the base case as 1 also, right? Where we return that number itself, correct? So we hit the stack, we hit the base case here, let's say. And then what happens is we come to the next, like we return from this and we come here. And what is the value of the previous one? Like we return with the value 1 from here. And what is the value that we'll have here is we'll have the current power is equals to previous x, which is 2 times the previous power. Previous power is 1, right? So we'll have 2. So we'll get this 2, and then what we'll do is that we'll return, like the second statement is executed, and the third statement, what we'll do, it will come again to the last stack trace. So what it will do is it will execute the second line. What does it, the second line say? Current power is equals to x, which is 2 times previous power, which is 2, because 2 was returned from the last one, right? Which is 4, right? And we can have this as the second statement. And for the third statement, what we do is, for the third one, what we do is we return to the last method call. And what will this give? Here n is equals to 3. So what will it give? Current power is equals to x, which is 2 times the previous power, which is 4. So this is how both the lines will be executed, right? The second as well as third. And as soon as the third line gets executed, this stack frame will be deleted, and we'll get our desired output. So let's try to run this once. So enter a number, let's say 5. 5 raised to 2, let's see, 5 raised to 2 is 25. Oops, we didn't print the value. Let me print the output response. Enter a number 5 to 25, right? Let's do this for another example, maybe. Say 2 raised to 4 is 4 4s are 16, 16, right? Right. Yep. So there is another approach where we can solve this problem, where we check if n is odd or even, and then we can have some logic, right? But we'll discuss that in the next video. So this is all for today. Thank you.